Hey guys, welcome back to the stream. Today we're doing calculus.
Okay, here's your warm up. Integrate this from 1 to B because it's full. Go ahead, take your head up, child. Yeah, well, you can sleep later when it's not in my class.
Oh.
It's kind of spinning.
Henry, it's this kind of day. Not early.
Oh, damn, I forgot we're integrating.
Integration, yes. Don't do the derivative when we are asking you to integrate.
It's been so long.
She hates people.
All of you in general.
What? This doesn't make any sense to me.
It's messed up.
What do you mean it doesn't make any sense?
Alright. LNB. Oh, no, only the zero. That makes sense.
Yes.
Okay. Got murdered out my
Say yes later.
Oh. Oh. Get the jail boys.
Right? The integral of 1 over x is natural log of x. Don't forget the jail bars as our fancy math words go. This one, raise the power, divide by the new power. Evaluate. Do we agree? Okay. So what we're getting to is something called improper integrals. And what makes something improper, like improper fractions, there's a whole number and a fraction, or sorry, proper fractions, top heavy. Improper integrals are ones that you shouldn't really be allowed to integrate, but we do it anyway. Yeah.
Tricks that are there.
Okay, so here's an improper integral. And we're not allowed to integrate to infinity. A is some number like 1, and then there's infinity. So they cheat, and let's see. They say, you know what? We're going to just integrate from A to B, and then go snicker, snicker, snicker. We're going to take B out to infinity. Okay, so I warned you yesterday, a lot of chapter 8 is formalisms. Like, you can't just use L'Hopital's rule. You need to do the irritating, pull the numerator out, check the limit, check the denominator separately. It's a lot of notation. And my numbers are going up on this. I'm evidently beating you over the head with, you need to show this formal thing. Improve. We're forming. So we need to do that. Is that all we have to do? What if it was this?
Give up.
Give up. Give up all hope. No. What do you think we would do?
Same thing.
Same thing, but the other way. Okay,
That's like not so bad.
that's not so bad.
Chapter 9 ain't so bad.
It's not chapter 9 yet. We're still in chapter 9 light.
I really like white square.
Okay, going back to this. What if I said, like, it's not just B, but I'm going to integrate those to infinity. And looking at the graphs, Chris, what does 1 over x look like? It looks like a poodle. What are you doing?
Just like, yeah.
He's doing that.
Like it approaches 0, like it gets small.
So it goes like this?
Yeah.
And that?
Yeah.
What does 1 over x squared look like? Okay. All of you back there are doing the conductor thing. 4 people in the back did this all at once. I'm like, hey, hit the downbeat. You're all off though. So, all right. They look a lot the same, yeah? Because I don't care about the left side. I am integrating 1 to infinity. Okay, well, here, if this is going to infinity, what's natural log of infinity? Infinity, oh. So,
Well, that makes sense.
okay, why the frowny face? We're going to get to this thing called convergence and divergence. And without telling you what it is, do you think this converges or diverges? Because it's going to infinity, and if you want to like catch it and contain it, it is keeps slipping away. Okay, well let's check this side.
One. No way.
-1 over infinity. Oh my goodness. So evidently the area under this curve diverged and was crazy. And the area under this one was like all well and good and came out to 1. There, Seth. Are we on to like crazy now?
Nah, it makes sense.
Liar.
How does
Does it
Yeah,
hit zero?
why
What is
does
like
that
the
work?
reason?
Nah, bro, think about it. Like,
No, but it's just not.
cause like,
How is
remember
one-
how we did like summations last year? With like, if you add up like 1 over x to the n a bunch of times, it's 1.
You're right.
Oh, it converges it to.
Yeah, that.
Yeah.
Converges to 2.
That's
Or
crazy.
no, yeah.
Yeah,
Yeah.
it's just
Didn't pay him. What kind of sequence is this? Series, I
a
should
long
say.
one.
Geometric series, which you can tell how.
Because it's always multiplied by a factor.
What did we just do? Just so crazy.
And then like arithmetic is that in the same thing?
Okay, arithmetic is completely different beast, but geometric, we're multiplying by the same thing each time. Seth, why do you know that this one is going to converge to a specific value?
Because I took pre-calc.
He's just smoking down. It's intuitive to him.
R, the number we're multiplying by, the ratio is 1/2.
It's less
Oh,
than one.
right. We learned that.
Because it's between
R is between 1 and 0.
If it's less, absolute value of that is less than 1, it's going to converge. Does anyone remember the formula for what it converges to?
It's
2.
1 over somewhere.
1 over.
1 over. Yeah, that's what I
Not
said.
1, but A, the first term. And the first term in this particular
It's
case
one.
is 1 over 1 minus 1/2, which is 1 over 1/2, which is, yes, 2, the thing you've been saying.
That's crazy.
So this one, I need to keep adding forever and ever to infinity. 1/64th, 2048 players, 1 over 128, 256, 512. You've got to keep going so that it comes out to actually 2. And he's like, really, it's Friday. Can we not do this?
Maybe we should all play 2048.
Yeah.
But this added to infinity, and I got a number of 1. This adding to infinity, I got infinity. And there's a difference, and this is kind of the crux of chapter 8 and 9. How are you feeling? See, Henry was like, she hates people today. Hence, bye. Okay. And this is the idea.
Bad day.
Well, you have no homework.
Well, you have a Diet Coke.
I do. Oh my god. Like half my department is absent with no reason. They're just like, tap out, I'm out.
So real.
Like,
So real.
my student aide, I'm like, you're teaching third period down the hall. What? Yep. Okay. So, what makes an improper integral an improper integral? I think I just said this in the beginning. So that first example we did, I'm sorry, Julian, you can't even see this, can you? Is it a to infinity, and we have to pull that limit out. Okay, so if you did the warm-up, you don't necessarily need to write this again, but we're not allowed to integrate to infinity. You need to pull a limit out and give it a letter. Whatever the letter you choose, please make sure it's not one that's already used in the formula. Like if you use X or T, don't put this being X. That's all. And then G, this one under here is, if we want to go to negative infinity, pull that out. Spencer, what if I wanted to integrate from negative infinity to positive infinity?
Damn, that sounds.
I don't know.
Negative A to A. And then says.
Negative A to A.
Just use
Okay,
zero to
they don't
infinity.
do that, and I'm not really sure why, and I think it's probably because it gets a little crazy looking. They pick a number, quote, in the middle. You can't find the middle of a negative infinity to infinity, but what would be a good number to break things at?
0.
0. So they chose the letter C, but often that C, most of you are going to pick 0. You don't have to. You can be crazy and be like, pi. I think Henry's maybe a pi kind of guy.
Radical.
Root 3, that'd be cool. But C can be any real number you want, but they and I don't know, I haven't graded one of these on the AP, but the formalism of it, you need to pull these things apart, and then the limit as A goes to negative infinity of this piece, the limit as B goes to positive infinity, yeah.
On the AP exam, if I was doing this, and I put like 10 quadrillion for C, would that work?
Don't be an asshole.
It's like,
Like, don't make things challenging for yourself, because you're going to have to evaluate the integral at that 10 bajillion number that you choose. So it doesn't happen often that they make you integrate from negative infinity to infinity, but there are times that you can, and you'll get a single finite number.
Isn't that like
It's definitely
with
happened.
arctan that happens?
Yes, on Arctan that
That's why
happens.
they like it.
It is one of the reasons they love it.
Is y squared 0? Or no, 1 over x, would that be 0?
No, it would be 2. But you can't actually integrate over the infinite
Because
discontinuity.
it goes up, it's continuous at 0.
It's discontinuous at 0, and it's an infinite discontinuity. So you can't go negative infinity to infinity of 1 over x squared, but you can go up to negative infinity to negative 1 and 1 on. So you got to cut out the middle strip. Okay, so we just did this. What does it mean to converge and diverge? Converge, maybe it goes to a single number, or you can put all the stuff in a box, is kind of how I see it. It's quantifiable. I can add it up. So 1 over x squared is the red one, and for whatever reason, that tiny bit of difference, the red one converges. The blue one does not. And we showed that this one converged because we did that integration. We integrated it and we got 1. We integrated this and got infinity. So converge, diverge. Good? So somewhere in here, between x to the first and x to the second, and I'm using positive numbers, but realize I'm talking about them in the denominator. Somewhere in there, it's going to break. It's going to change from being integratable to a single number and not. Any guesses, insights on where it might break? Julian?
I feel like maybe anything over 1.
So 1.0001 is going to make it break?
Yeah,
Okay, why do you think that?
because you were doing like the 1 minus the other stuff and the other formula. But I don't know.
Okay,
Is it because
Daniel?
Yeah, I was gonna say something kind of similar, because then it wouldn't integrate to be ln, it would integrate to be like a polynomial.
Okay.
Oh, yeah.
that's what I was gonna say?
Okay, so, yeah, all right. 1 plus a teeny tiny any little bit. When you raise the power, there's going to be a little bit of stuff still down there. So yeah, the breaking point is exactly 1. Because if it's x to the first, as Julian said, that integrates to natural log, and then we're going to have to do natural log of that infinity. But if it's 1 plus a smidgen, that smidgen is left behind, and the infinity is plugged into 1 over infinity to a smidgen is still infinity. Yeah.
Does it also work for like 0.99999?
Well, if it's we'll just make it 9/10, okay?
Yeah.
So raise the power, negative 9/10 plus 10/10, x to the 1/10. Look at me modeling proper notation to infinity, but I'm going to pull it out as the limit. When I evaluate this from 1 to b, infinity to the 1/10, it's even bigger than natural log of infinity. So if you make it, if that exponent is 1 or smaller, and by smaller I mean 1, 1/2, 1/3, smaller than 1, it's going to diverge. So again, we just did this. Let's see. Do I show you this yet or not? No. All right. Yeah, not yet. There's a name for this. And I don't see the need to do the ones that we just did several times. Ooh, not that yet. There's a thing called P series, power series. If you're given that, where converge, what is the exponent, that value of p going to be if it's going to come to a finite number?
Great.
Greater than 1. And when does it diverge? What about when it's equal? Does equal make it converge, equal to 1 converge? Or?
Diverge.
And again, the p is in the bottom already, so it's kind of implied that you know that it's in the denominator, so I'm using positive numbers. But if it's 1 over x to the 3rd or x to the 5/3, they're different things. So, okay. Chapter 8 and 9, we're gonna get to formalizing when do things converge and diverge. They wanna know if this is a model for this scientific problem and it goes on forever this way, are we gonna be able to manage the problem? Or is it gonna get out of control? And there's an acronym that I use for it. Parting the seas. Oh, send my biblical reference, so sorry. P series is one of the first ones. And T, we don't do that one, but an acronym doesn't work without the T, so I'll show it to you once. Then we'll move on.
Do we have to know all of those? Taylor series.
Telescoping. Taylor series is all of chapter 9. Yeah, what is Taylor series? Come on, mister, I sleep through math class. What is Taylor series?
It's
Like where do you think, like, and then the budget is it, like higher order?
The polynomial approximation.
Polynomial approximation, what does that mean?
You take a not polynomial and approximate it to a polynomial.
Basically.
pretty much.
So, guys, chapter 9, you take a not polynomial. You do a whole bunch of derivatives and then you force it to be a polynomial. Yes, very cool.
Did you show us this one time?
I did.
It was like
She's shown us many
alternating odd numbers over
So-
odd something.
You should just do that now.
Wait, what is the?
Yeah.
Telescope.
Wait, what?
We should not do this now.
We should not do this now. But it's happy. So,
No.
X
That's
over X
sign.
factorial is one.
Oh.
How though?
how though?
That's a
I
lot.
don't think it is.
Does the first one be
Does it look
X?
like
You
that?
will
I
know
remember
soon
this.
enough. What?
Should the first one be X?
First one should be X.
Oh.
So now it's signed.
Wait, so what's the point of doing all that?
Always on fire.
It really is.
And if you notice, like, is sign even or odd? Odd, gee. Look at all the numbers. Odd. Cosine is even or odd? So,
What about neither?
hold on. That's later. This isn't either. We'll get there. What is 0 factorial?
One.
Why?
One up.
Because that's how it is.
Because it's like 1 times
Because it's like,
One
you can only
times.
say no one way.
0, 0.
You can only say no one way. So 0 factorial, there's one way to say I abstain from voting.
Well, you know, you could like tweet about it. Or,
No. I don't care about your method of communication. You can just say no through Morse code, smoke signals, whatever. I don't care your method of communication. But there's one way to say no, I don't vote for any of those. And what is x to the 0? As long as it's not 0. 1. So this is okay. So if this is sine, cosine is going to start off as 1. What do you think the next term would be? 2? 4.
Why does it switch like minus plus?
Well, yeah. Again, we're doing chapter 9 right now. Off script. No. I have.
So I do all that.
Why do all this? Okay. Your calculator does not know how to do sine. Your calculator does not know how to do ln. Your calculator does not know how to calculate e to the x. And if you're taking any engineering classes, your calculator does binary, period. Or your calculator, your computer, it only knows the light is on, the light is off. How do you make a computer add?
You use an adder.
you get the
Like,
plus
watch
sign.
On
it.
and off.
Yeah, you turn on and
We actually
a little.
Add one, you turn the first light on. To add another, you turn that light off and then the next one on.
And then you,
And then you add one.
yeah.
It's also known as shifting registers.
So,
Do
so
it
the
now or not?
calculator doesn't know.
All your calculator knows how to do is add. Okay. How do you make it subtract? You add negative numbers. How do you get to multiply? You make it add multiple times. So how do you make it do sine? You create polynomials. What are polynomials? They're just glorified multiplies with adding, which is also just adding. So this is the way that all of these devices that you use, what it comes down to. This is what you get, that you have a computer scientist from the 80s as your math teacher. I know this stuff.
Is there like any sort of calculator that can like do it?
Well, in the end, that's what it comes down to, is it does a bunch of adds.
Actually, I'm saying it's like, is there any calculator that
An analog
Like-
one.
doesn't just add?
Um,
ChatGPT.
Going with no, because in the end, it just, unless your computer is like
Someone's gotta make
the
it.
HAL thing where it's an actual human integrated into the circuit. Sorry, Dave, I can't do that. Never seen Space Odyssey, you're not gonna get that. Okay, anyway, so it's also faster if you do polynomials than if you do e to the x. Like if you force it to model the e to the x to too many degrees of accuracy, it takes too long to process. Like another former job that I had was we did safety critical systems, and some of the things like Hurricane Katrina knocked out bridges and things, and you need to evacuate the city. What's the fastest way out? And the information is constantly changing. This bridge is out, okay, you need to turn everybody this way, and now there's this huge clog there. How do you get people out in these emergencies? So it does things that, with the information I have right now, here's the best answer I can give. So in physics, if you need a quick approximation, instead of saying sine x of 0.3 radians, you can just be like, well, because I know the polynomial approximation, I'm just going to say it's x. So it's about 0.3. It's much faster to say 0.3 than sine of 0.3. If you get too far away from 0, then it's less accurate. If you're doing sine of 2, then you're wrong. You're just straight out wrong. Sine can never be 2. Okay? Mister?
Pretty cool.
Okay. Yeah, we'll try this. It's painful. Back to our regularly scheduled program for about 5 minutes. Ooh, dude.
You do this guy.
Yeah. When do I have to do that?
Can you push the limit inside the interval?
You can. Why would you do that? I mean, no, because that.
No.
Mhm. There's so many things in this problem. How do we integrate that?
You gotta do the voodoo.
You gotta do the voodoo one that is pointing at the wall. Oh, so lipid integration by parts, voodoo, however you want to call it. So, could we do tabular?
Oh wait, we could.
We could
I
do
mean, it's the
tabular.
same thing.
Why can't you do U substitution?
What's the u value?
E to the x, is that not?
The derivative of e to the negative x is negative e to the x. How do we get this guy wrapped in? Like,
Yes, we can.
the collective is right, but we need to do the voodoo.
I forgot.
What's the u value? X. What's the du?
One. Oh, you said du.
Okay, du is 1 dx. What's the inner rule of e to the negative x? Negative e to the negative x. You guys remember this?
Yeah.
Okay. So uv minus v du negative negative becomes plus. Oh, goodness. This one is all the marbles. Sorry, Chris, what?
We do tabular or not?
You could. It's one step in tabular, it's one step in integration by parts. I don't see it being a big win doing it. But whatever way you want to go.
Thank you.
Just to integrate everything at once and deal with it. Integrating e to the negative x again is negative e to the negative x, and we're evaluating from 1 to b. What do I do? Well, so putting in infinity here,
No, not.
The chapter like you like in B and one.
I guess
Do
you
the
gotta
one
do
and the
something
B and
with
then you gotta do.
the hospital.
Something else.
I got
Okay.
it.
It's 0.
How do you think negative x is 1 over 1 over
Make that up.
so I plugged in b and I plugged in 1. Did I do that right?
Yeah.
So over here, I get minus
1 over
minus 1 over e minus another 1 over e, so it's negative 2 over e. Yeah?
Yeah.
This guy's the pain in the butt to handle. Well, because you read the title, we got to do L'Hopital's with this. I don't have a.
The e moves down.
Okay,
The E moves
so
down. And then.
L'Hopital's only applies in fractions. That was negative b over e to the b minus 1.
And that's infinity over infinity.
That's infinity over
So then you
infinity.
gotta do the-
But we need to be formal about it and say, as this goes to infinity, that's negative infinity. And as this goes to infinity, that's positive infinity. And it doesn't matter that the signs mix and match. I'm okay. All right, so then L'Hopital's applies because I checked it over there. Derivative of the top is, thank God, negative 1. Derivative of the bottom. Whew. So that goes to 0. So this whole thing integrates to be 2 over e. Yeah.
Why can't you just plug in infinity for B, like 2 steps up?
Is that 1 over e to the b? Chain rule.
Derivative
Not,
of
not
the
that one, up one.
here, like here, I rewrote the problem like this,
Yeah.
and then I had common denominators. So these, I didn't chain rule any. I didn't do any calculus from here to there. I just did algebra, which made the derivative so much easier to manage. But the derivative of here is a -1.
And
And -1 over infinity is the same as +1 over infinity. Whatever you're slicing up between an infinite number of people effectively is 0. Okay. Chain rule the bottom, the denominator, e to the b, chain rule how?
But it's even negative.
No, so,
No,
okay,
because
In real
it was
life.
moved to the bottom, 'cause it was negative when it was at the top, and then the bottom is just b. So it's negative b, it's just the same as saying 1 over the.
The derivative separately.
Like, you moved it.
set a to the -2, isn't that 1 over a squared?
Yes.
So the sign changes?
Yes.
So e to the -b up top becomes e to the positive b on the bottom.
Yes.
True?
So then we don't change, there's nothing to chain rule. Derivatives
Yeah.
either b.
For the hospital thing, you do the derivative of the top and bottom separately.
Correct.
Oh,
We are not reinventing how to do quotient rule.
Derived
This is a
over
specific thing for L'Hopital's for limits evaluating in this special condition.
No, because
So
this
can you
is
not have
dolls,
one?
bro.
Oh.
Product rule still applies if you had a product up top that was part of your derivative.
Oh,
So correct, I got you.
well, what if there's a denominator in the top?
Look at those.
Denominator at the top.
That's crazy.
If you had a fraction in your
Yeah.
thing here, which we've done, we forced those things to happen in our L'Hopital's practice stuff. We were like, oh, we're gonna multiply by this. If you forced a quotient to happen, which this might happen, you do the derivative of, like, this I would do power rule, multiply by the power, lower the power, because the top is just a constant.
Oh.
It shouldn't, from what you guys are doing, it shouldn't be too fancy.
Okay.
Okay, is a mandatory non-homework day. So, did you guys have questions on the homework that was assigned previously?
You mean the one from when you were out?
Well, any of them.
Can you go to 7?
7 from last night?
It was,
This guy?
Yeah.
First of all, okay. First of all, you guys should have some insights to these. What is your inclination? E to the cosine versus e to the x?
Gotta be e to the x.
Like, which one's gonna grow faster?
E to the x.
E to the x, because x gets bigger and bigger, and cosine is stuck between -1 and 1. Okay, so if we were to check this,
Hey DCC, this is Sanjana Surendran and Tali Goldman with your daily announcements. Today is Friday, February 17th. Please stand for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Extra, extra. In today's Find Out Friday online edition, the Tadler explores rising incidents of racism at BCC, increasing violence against staff members, our editor-in-chief of CFBB's response to the rock opinion piece, and more. Don't miss it today at bcctadler.org. Hey Barry, did you know that today, February 17th,
How to do this formally?
is Acts of Kindness Day?
I don't know.
Yep. Today's a day where kindness is celebrated and encouraged.
Well,
Studies have been shown that having a
like that,
program
say,
kindness